Well, it's Friday and not done any CBs for a couple of days. COVID jab was Wednesday. I've survived that, and other things to do. So we've got a Murphy DS602. I said last week, whenever it was we did a Murphy DS602, which was in a box of junk here, that we're expecting one from a customer. This looks like it's been resprayed, but it looks nice. Comes with a factory standard microphone and an enormously Tonka power lead. Considering these draw about 1.2 amps, I'm not quite sure what that's about. So I better check this fuse because the radio needs protection. Well, he's not going to give any protection with that. It's 10 amps. So I'll send that back so he can use it in his car or whatever it belongs, and we'll put a 3 amp fuse in. Right, that's the safety bit out of the way. Screw missing. I always see these big fat. Oh, I don't know what's supposed to even go in these. Yeah. It'll get 2 screws back as well. Just undo with the speaker. They've got white to the right, which is the positive, not that it matters, but just for the crack. Just look underneath, make sure there's no horrors. I've said before these were made by, made for Great Universal Stores, which is mail order catalogue in the UK. It's custom manufactured for them. It's very similar circuitry wise to the JWR-M2, the ICOM ICB 1050, and I've said a million times before, nothing to do with the communications company ICOM, just a random name that they put on their radio. It could have been Umbrella, but it was ICOM. So we'll just check how this is working before we start doing anything to it. I don't think we'll bother undoing that and just plug it in and use our crocodile clips. So we're on at 13.8 volts. Certainly in better condition than most. Switch picture in picture on. This customer was the same one who's got the Maxcom 20 we did a few days ago. TX, switch it on, select channel 20. Watts, deviation, wallow, 1.5 kilohertz, which is pretty low. Check it's on frequency. So it should be 79125. It's within tolerance at 79033. we'll correct that right at this moment. Is that capacitor looking poorly? I've actually gone the right way for once. That'll do nicely. So that's done that. I'm just going to look at that capacitor a bit closer. No, I don't think it's bulging or anything. It's just, it's got caught at some point, probably in manufacture, and the top of the lip of the heat shrink tubing has got cut. I think we'll change it as a matter of course, though. Well, what are they, 16 pence or something? Right, so that's transmit. Let's look at receive. We've also got on the shelves a couple of brand new, what do they call it? Thunderbolt T3000s, those front to back very short radios for optimization. They've come brand new, and the same customer, a couple of those Midland 42 handhelds for optimization. I think it's the DS one, which we've not had before. So we'll look at those. And another customer, who's an end user, has sent in an Amstrad 900 in a box. And the good thing about Amstrad 900s is they're always the genuine article, and they're always made in Japan. So that's going to work quite nicely, I'm sure. Whereas the 901, you ended up with the cheaper version, and you also end up with the fake version, and so those don't quite work as well. So let's see what we've got on receive. So I'll turn the volume up. Better plug in the test instruments to the extension speaker socket. No audio. It's showing on the meter, but I've got no audio on receive. So let's see whether he's got audio at the speaker. Yep, no audio at all. Well, it looks like we're going to have to look into that. This is where you wish you got public address facilities, because it's very quick to just check in PA mode and see if you've got the PA working, because then you've kind of proved all the audio amplifier circuits. But on sets with no public address facility, it's a bit slower trying to fault find. Of course, the switches can play up in CB radios. I'll just we've got a handy crocodile clip lead. Yes. I'll just put that on the negative end of my. I'll tell you what, for a start, we'll check that the instruments are connected. Don't want to start chasing faults which aren't there. Right, so that's okay. I'll just connect negative to negative. Get that meter back. I think it's a negative chassis on this. It's a negative chassis. It's not a negative chassis, it's a floating chassis. Nope. The only thing that usually plays up is the audio IC if somebody's put wrong speakers in or reverse polarity or had the wrong fuse in. Now you often see, if the audio IC's had it, you will often see bulging of the actual plastic case of the audio IC, and it looks absolutely straight to me. Now although this isn't going to fix this radio, I'll just do this capacitor, so we'll come back to it. So it's a 1 microfarad capacitor, so I'll get rid of picture in picture, we don't need that. So we'll just see whether it's working or whether it was just a physical cut. .2, well, it's about there, isn't it? So we'll throw that away. I've done the right thing, I've put a new one in. Now, without looking at the pin out for this audio IC, we'll just make sure it's got power going to it. Well, that's interesting because we have 2 volts on the second pin along, whichever pin that is. There's absolutely no way that is correct. Just check we've got 13 point. Yeah, we have. At the voltage rail. Of course, it would help if I switched the radio on. Let's try again. Full rail voltage where I'd expect it to be. That's today's deliberate error. Well, we've got power and we've got no audio. So the next thing to do is I'll just connect the speaker back again. Okay, well, you know what? Since we changed that capacitor, it now works. There's a dry joint somewhere down there. Right, well, I found the dry joint. So now we'll rectify that. It's actually a cracked piece of track. And it's just there. So what we'll do is we'll put a piece of wire across that. There's no point just putting a blob of solder on because it just won't stand up to being in a car. So we'll put some solder at that end, put some solder at that end, and we'll lay that across there. And then we've got some mechanical rigidity. There's a good word. Yay! Right, we'll go back to picture in picture. I'll select the cyanide meter. So 12 dBs. Let's have a look what it's doing. It's very healthy. 0.59 microvolts. Just look at 10. 0.485. And let's see what if we can get 20 on it. We can. And we've got that at 1.35 microvolts. Right, so having made the radio work, let's see whether we can actually improve it. I've got the soldering iron on, as you know, because we're going to need to melt. I don't think it's being touched. So we're on channel 20, we'll go into transmit. We'll go on the bigger scale where it's 3 watts. 3.1. Do with the bigger one for that. It's the bigger one, alright, but that's the Phillips type. So that's 3.3. .6. Just run through those again. Yes, we look to be about 3.6, which we'll look at that on the spectrum analyzer. But first of all, we'll do the deviation while that comes on. I think it was that one last week. No. It was that one then. Yeah. Wallow. Spot on. So that will be low power. May as well set low power. So it should be 400 milliwatts. That's 400 milliwatts. Back to high. Right, we'll see what the spectrum analyzer has to say. Frequency 27.79125. We'll measure that. Minus 58 dBm. Oh, I'm not showing you. What a wally. So there's our spurious on 54 megs, whatever it is, 55. And then just go back. And there is our fundamental. Right. So that's actually fine. But it's not being fiddled with, you can tell. So I'll turn that off. So it's, has it cooled down a bit? Let's see what it's doing. Yeah, 3.6. Okay, so what does that leave? It leaves us to do the meter. And we want it halfway into the red zone, like that. Then we'll go on low power, it hardly moves. So that's the transmitter done. So we'll now do receive. And we'll start with the oscilloscope, an S9 equivalent signal, and enough volume for me to adjust the detector. They've hidden these under the wiring harness today. Oh, very slight advantage there. And we'll just do this IF one. Just make sure the detector's still right. Yeah, I don't think we're going to do better than that. Well, clearly the radio had a fault, didn't it, with the crack. So let's see what we've achieved, if anything. Well, that's 0.3 of a microvolt you're hearing. Let's have a look. 12 decibels is 0.35. 10 decibels 0.295. 20 decibels 1.1. Right, so we'll set the S meter, we'll put an S9 signal on, which is 100 microvolts for CB in the UK. It's the one on the left. It's absolutely spot on the 9. There isn't a squelch adjustment, and of course that's the snag with these sets. So, no squelch adjustment, all I can do is tell you what it's doing. So I'll turn the signal generator off, we'll put the set to full squelch, we'll turn the signal generator back on, 3 microvolts, that's it. Maximum squelch, going off at 2 microvolts, coming in at 3. So if you live in a congested area radio-wise, it's a very weak squelch. There's absolutely nothing we can do. We don't modify radios here. I told you the story about the lady who didn't seem to like men very much, but I did have to alter her radio when she was throwing her weight around in the workshop. So, we're done. That's it. So all that needs to happen is we need to put it back together. If this were my own personal set, I would rethread the screws for something which fits, probably M4 or something, rather than just put the 2 self-tappers in as we're presented with. But it isn't my set, so the safest course of action is to put the 2 screws we've been given back. if at 3 o'clock in the afternoon we can hear any good buddies or even bad buddies out there. So in actual fact, when we put it together, the speaker's duff. Our speaker, internal speaker.
Right. What's his name?
There you go. So I have to change that. Luckily we've got them in stock. Customer said he thought the speaker was duff, but it's not very often, and I've had to change. Funny enough, I've had to change 2 in the last 2 weeks. But we don't get it often. I'll be surprised if I had to change more than 1 a year, and we're doing probably must be doing 350 sets a year. So I'll get that changed. Okay, so we'll try again. Mount a new speaker. Alright, we'll switch on.
Can I have a scarf? Can't be any worse than the smoke coming up from downstairs.
Oh, we're on channel 37. Yeah, well, it does sound how it should do now. I'll send him that speaker back, but I don't know if you can hear. If I just move the cone, I'll just put it up to the microphones. It's rubbing. One Anna Roger. Right, well, we'll leave it at that, and we'll do an on-the-air test. So thank you for watching the Murphy DS602